Okay, so this is the recorded lecture that's replacing lecture for today, so that's December 5th, 2017. I apologize for not being able to make it to campus today. So we're going to finish up chapter 6 and then do all of chapter 7, and then there will be an assignment posted in Canvas that goes along with this recorded lecture, and you should complete the assignment before exam 4 on Thursday. So we left off talking about autism. We had left off last time with the group assignment. So prevalence of autism has been increasing recently. So right now the prevalence of autism is 1 in 68 children. So that's about 1 to 2% of the population. This is already higher than the rate was when I started in this field. So when I started, I remember it was 1 in 159 or something like that. So it does seem to be increasing. Autism is more common in boys, so it's 4 to 5 times more common in males than females. So the current rate in boys is 1 in 42, and the current rate in females is 1 in 189. These rates seem to be comparable across racial and ethnic groups, so the rates of autism don't seem to vary much across those groups. So in terms of thinking about why we're seeing this increase in prevalence rates, there are a number of different ideas about this. So one main idea about why we might see increased rates of autism is simply that we have improved our ability to detect autism. So that's a positive thing. We'll talk a little bit about this later, but basically if we can detect autism earlier, we can do better intervention. And so there's a lot of work that's been done in the last 10 years to improve early intervention efforts, and thus we've become better and better at identifying autism. So in becoming better at identifying it, we may be driving those prevalence rates up. We also have included some broader diagnostic criteria. So for example, IQ has been included in diagnostic criteria. So just by broadening the diagnostic criteria, maybe including kids under the autism category that before we weren't including. So if you see down at the bottom of the slide here, you can see that over the years, as from 2000 to 2010, as rates of intellectual disability decreased in the U.S., rates of autism have increased. So the idea here is that we've sort of taken kids that we used to label as intellectually disabled, and now we're labeling them as autistic. So it's not that prevalence rates of autism are actually rising necessarily, but just that kids who used to fall under different diagnostic categories are now following under the category of autism. There's also greater cultural and societal awareness of autism. So parents are more aware, teachers are more aware, school administrators are more aware. So this may be alerting people to symptoms of autism that they used to not be alerted to, and therefore increase these prevalence rates. There's also better access to services in general now than they're compared to what there used to be. So this is one reason why kids may be getting those diagnoses, whereas before they weren't able to. We also know that increased parental age is related to increased risk for autism. So having both a mom and or a father who is at an increased age, meaning over 35, when the child is conceived, is related to greater risk for autism in the offspring. And there is a trend societally, especially in the last 10 or 20 years, for parents to be a little bit older than they used to be. So this could be one reason why rates of autism have increased. We can't rule out the possibility that there may be environmental factors. So there have been a number of ideas about environmental factors like vaccinations or lead or other, there's a million environmental factor theories about autism, and we can't rule them out. But at this point, we don't have substantial research evidence supporting any one of these environmental factors as being causal in the increase in prevalence in autism. So we talked a bit about this at the beginning of this course, and this was basically the study that came out in 1998 from Wakefield, and the study was basically connecting autism to vaccinations. So it supported this claim that vaccinations cause autism. Several studies tried to replicate this afterwards, and they were unable to. And then it came out that Wakefield had actually altered the medical histories of some of these subjects and had to actually retract the article in 2004. But it was a little bit too late by that point. So even though that article was retracted, and in the scientific literature, this idea of this cause between vaccination and autism has been debunked many times over. There's lots of data, pretty convincing data, suggesting there is no link between these two things. That idea already sort of leaked into pop culture and media, and it has been pretty hard for the field and society to sort of get rid of this idea. And so as a result of this, parents have been immunizing their children less and less, and this has led to increases in measles. So there's some real problems that come up when people come up with sort of causal mechanisms, environmental mechanisms that may be associated with things as devastating as autism. And when the science that is based off of in the first place wasn't good, but then even once we do a lot of work to retract those findings, it's hard for us to remove or take away the damage that may have caused. So in any case, we're pretty confident that vaccinations don't have to do with or are not a cause of autism, but we are not able to fully say what causes autism. It seems like it's not one factor all by itself. It seems like there are two sort of overarching causes or potential causes of autism. So one group of those causes is genetics. So we know that there are susceptibility genes. We have identified some of those. We've identified some specific genetic mutations that relate to autism. We do know that this not only is autism itself heritable, but we know that characteristics of autisms are heritable. So 15 to 20% of siblings of individuals with ASD have the disorder. And so we said the rate of autism in the general population was 1 to 2%. So this is a much higher rate in siblings of autism compared to the general population, suggesting there is heritability here. And not even just the disorder itself, but we do observe that siblings and relatives of people with autism have higher rates of general social deficits. So this, as we talked about, this is a spectrum disorder, and so even if relatives don't actually meet criteria for autism, they often fall on that spectrum or have some impairment that may not even be clinical, but they do seem to have social deficits. So that leads us to believe that this may be a heritable disorder. It has to do with multiple genes that kind of come together to cause someone or underlie the cause for someone to have autism. We also know that there are some environmental causes related to autism. So I should say correlates, not causes necessarily. So we know that being a premature infant is related to increased risk for autism. We know that having a low birth weight is related to increased risk for autism. We talked earlier about having a relatively small head, and then between months 6 and 12, head size grows, and so that by the age 1, kids with autism have relatively larger heads. So head size seems to be something that may be related to autism. General birth complications are related to increased risk for autism, and then, like we also mentioned earlier, parental age. So having parents that are relatively speaking older, so over 35, it causes kids to have more of a risk for autism. In terms of how we diagnose autism, we don't have a medical test. There's not a blood test or an MRI that you can get to have a diagnosis of autism. we do what's called the best estimate diagnosis, meaning we do a variety of clinical interviewing and questionnaires and observations in multiple settings to determine whether a child meets criteria for autism. So clinicians will do behavioral observations across different contexts. So they'll do this in the clinic, they'll do it at home, they'll go to a school if the child is in school already, or the park, anywhere the child may have access to social interactions, to do structured observational measures for symptoms of autism. There is a semi-structured assessment called the ADOS, which is, in our field, the gold standard for diagnosing autism. That the ADOS is something that is, it involves extensive training on the clinician's part and a lot of work to become reliable in rating symptoms for the ADOS. And this is something that is done in the clinic. So there are a series of things that, interactions that take place during the ADOS, and the child's behavior is coded by the clinician. Clinicians will also do structured and unstructured interviews with the parents and maybe other family members, maybe teachers, to try to gather information about potential symptoms of autism, questionnaires. And so basically clinicians come up with a full picture of symptoms across contexts, across reporters, using multiple methods, and then they come up with the diagnosis of autism. So in autism, we know that early intervention is particularly important, and the earlier the better. So we know that if we can identify kids who have autism or who are at risk for autism and intervene as early as possible in development, this results in better long-term outcomes. So parents should follow up on concerns as soon as they notice them. So as soon as they start to notice anything abnormal in terms of social interactions, or cognitive deficits, or rigidity, like we talked about, repetitive movements, they should bring their child into a clinician as soon as possible to get an assessment. Once a diagnosis of autism has been made, then intervention should occur immediately after that, as soon as possible. And usually intervention is early and intensive, so usually 25 hours a week or more. So this isn't like bring your child into the clinic for 1 hour per week therapy. Usually a therapist comes into the home or the school, depending on the age of the child, and works for many hours per week with the child. These are usually one-on-one interactions, sometimes small group instruction. The intervention is highly structured. So it isn't talk therapy. It is usually applied behavior analysis, and it's very structured methods of increasing social skills. Intervention attempts to be naturalistic, so therapists go into the family's home, and therapists work with parents and siblings to get everyone on the same page in terms of the intervention approach. They hope that the skills can generalize across settings, so they try to do the intervention in multiple settings. So the basic approach to early intervention strategies are learning and behavioral. So that's a lot of what we've been talking about, using behavioral reward contingencies to get kids to increase their social skills. They tend to be developmental, so they focus on where meeting developmental milestones. Relationship focus, so they try to encourage the relationship between the therapist and the child as a way of modeling appropriate social interactions. And then a lot of structured teaching, so lots of schedules like we talked about, and visual aids. So on the right hand side of the slide here, you can see that this is an example of a schedule someone might use with a child with autism, where there are images depicting the activities the child's going to do, like writing or math, and then you would put one of these images in the schedule lined up in that order, so that children would have a visual aid to know what they're going to be doing throughout the day. One of the main ways that people intervene, that clinicians intervene with kids with autism, is by using ABA, or applied behavioral analysis. So there's a YouTube video here at the bottom of the screen that is a very good description and example of ABA. Basically, ABA uses a lot of behaviorism, so looks at contingencies between behavior and the environment. ABA therapists identify target behaviors. So for example, if they want to increase the amount of times a child says hello to someone when they walk in the room, saying hello might be a target behavior. And then it uses positive reinforcement to increase that target behavior. So this is very behavioral. And then it relies on extensive data collection. So ABA therapists are basically always carrying around a clipboard or a piece of paper with them, and they're sort of keeping track of behavior and reward contingencies as they go. So go ahead and watch that YouTube video for more information on ABA. So some other intervention approaches include speech and language therapy. So this is for kids who do have impairments in speech or language. Social skills training can be useful for kids who have specific deficits in social skills. Parent strategies, so especially kids with behavioral problems, which is quite common in kids with autism. Parent strategies can be helpful for managing those challenging behavioral problems. And then anxiety-focused treatment. So many kids with autism also have anxiety disorders, and so that can also be targeted in treatment, and as well as executive functioning, which would include trying to increase planning and flexibility. Okay, so now we're going to switch to talking about Chapter 7, focusing on communication and learning disorders. So we're going to define the two types of learning disabilities in the DSM. We're going to describe the basic components of language development and phonological, having trouble with that word, awareness. And then we're going to describe the main features, prevalence, and causes, as well as treatments for specific learning disorders, as well as communication disorders. Then we're going to distinguish social communication disorder from autism spectrum disorder. So in the DSM-5, learning disabilities come in two varieties. So the first is communication disorders. Communication disorders are basically difficulty in producing or understanding speech, using speech to communicate, or speech fluency. Specific learning disorders have to do with very specific problems in reading, math, or writing. So the two broad types of learning disabilities in the DSM are just basic problems with communication, and then a specific learning disorder, meaning a reading disorder, math disorder, or writing disorder. So to get a specific learning disorder diagnosis, this is going to be displayed as an unexpected pattern of weakness relative to a child's IQ. So just having a generally low IQ is like what we've talked about earlier in intellectual disability. But if someone has a relatively high IQ but a specific problem with achievement in reading, math, or writing, then they're going to have a specific learning disorder. So learning disorder is a discrepancy between your IQ and your academic achievement. So basically, given your general IQ, we would expect you to be able to perform at a certain level in reading, math, or writing, and if you aren't able to do that, you may end up with a diagnosis of a specific learning disorder. So basic language development, and this is normative language development, has to do with phonemes. So phonemes are the basic sounds that make up language. So for example, ba or da, these are examples of phonemes. In the English language, there are 42 different phonemes, but every language has its own variety of phonemes, so there are different numbers of phonemes in different languages, and we don't all share the same phonemes. So some phonemes are only present in one language and not in another. In terms of how auditory and perceptual maps develop in children, they're detectable by 6 months old. And by 6 months old, they begin to differ by country. So by 6 months old, kids begin to be able to decipher the phonemes in their country's language and not the phonemes in another country's language. And then by 1 year old, they're no longer able to distinguish unimportant phonemes at all. So there are some phonemes that are not present in the English language. I'm not going to be able to pronounce those phonemes. And so research has shown that in infants younger than 6 months old, those infants can actually hear those differences in those phonemes. But by age 6 months to a year, children lose the ability to hear phonemes that are not in their home language. So your brain is becoming very specialized and very good at hearing the phonemes that are relevant to you, but you lose the ability to hear phonemes that are not relevant to you. So in some sense, through that 6 months to a year, we're becoming less good at distinguishing phonemes in other languages, but we are becoming more good, and we're becoming experts at distinguishing phonemes that make up the sounds in our language. So in terms of second language learning, it's actually easier for kids to learn a second language if they're exposed to it under 1 year old. So if they heard two languages under 1 year old, there may be some delays in that language acquisition, but they're going to be, in general, better at learning that second language than if they're exposed to that second language after the first year of life. So this YouTube video down here is actually really interesting, and it goes into the research I just talked about. The researcher that presents this is very famous in her area for discovering this phenomena where kids are learning how to distinguish phonemes over the course of development, and the really interesting thing is that infants younger than 6 months old are able to hear all the different phonemes in all the different languages, and we basically lose that ability by 1 year old. So go ahead and watch that video if you want to know more about development of language. So I'm not going to be able to say this word right now. Phonological awareness is, I'm having trouble with it, is making connections between sounds and letters, being able to detect rhyme and alliteration, manipulating the sounds of language. So for example, being able to say hat without the H sound, or something like this. What word do these things make? T-I-N, being able to translate that into tin. And so these abilities predict long-term reading and comprehension later in life. So basically, and we're talking about after 1 year old, your ability to make connections between sounds and letters and manipulate sounds in the language is going to predict your ability to read and your comprehension across your lifespan. So these are pretty important skills. Okay, so in the DSM, under the broad category of communication disorders, there are these specific types of communication disorders. So language disorder, speech sound disorder, childhood onset fluency disorder, which is basically stuttering, and social or pragmatic communication disorders. So we're going to go through these in more detail. So language disorder is basically an impairment in understanding, which is receptive, or using language, which is expressive. So you're either having trouble understanding language or using language to communicate. It has to do with difficulties in comprehension or production. If receptive language skills are poor, children can seem inattentive or non-compliant. So if parents or teachers are not aware of this language disorder, it can seem like kids just aren't paying attention or aren't willing to do the things that you're asking them. It can look similar to how someone looks when they're in a foreign country and they don't know the language, and someone's saying something to you like, move out of the way, and you're not moving. It can look like you're being non-compliant or you don't care, when really you're having trouble with your receptive language skills in that case. So one of the hallmarks of a receptive language skill deficit in a young child is one that just a child looks confused and seems inattentive or non-compliant when really they're having trouble comprehending language. Speech sound disorder, or SSD, is basically having trouble controlling the rate or articulation of speech. So for example, if a child says wabbit instead of rabbit, and has trouble with the R's in general, that could be a speech sound disorder. So these are really specific types of disorders, and usually speech therapists would work with kids who have speech sound disorders. They're more common in young kids, and they become atypical after the age of 3 or 4. So in terms of prevalence for language disorders and the speech sound disorders, they're pretty common in early childhood. So about 10% of kids in early childhood will have some sort of difficulty with expressing themselves in language, or a receptive language, or having some sort of specific speech sound issue. But by age 7, it becomes relatively uncommon. So 2 to 3% by age 7, and then by school age, 7%. 50% of kids with these language disorders and speech sound disorders will fully outgrow these problems. So these seem to be things that, at least for the most part, our kids are naturally outgrowing these issues. If kids have trouble with receptive language, meaning being able to hear language and comprehend it, these kids tend to have more trouble in treatment, so they're more treatment resistant. They have a poor prognosis, and this is associated with difficulties in reading, specifically. Language disorders and speech sound disorders are twice as common in boys as girls. And they are related to more negative behaviors such as social skills problems. And this could have to do with the fact that language is important in early childhood for social interactions and for kids to get along, or maybe just that having a language issue could cause a lot of frustration for a child and a lot of confusion, which may lead to some negative behaviors. So this is why it's important to make sure these kids are included in normative classroom settings so that positive social skills can be modeled for them, so that they don't end up with social problems on top of their language problems. In terms of causes of language disorders and speech sound disorders, we know that quite a bit of the variance is explained by genetics. So 50 to 75% of kids with these disorders have a family history of these disorders. This data comes from twin and adoption studies. We know that there are some neurobiological issues associated with language and speech sound disorders, so problems in functional connections between brain areas. Middle ear infections early in childhood can also cause issues, so these can cause delays in speech. It's possible for kids to catch up, and they usually do, but if you have an ear infection or chronic ear infections, especially early in childhood, this can cause some issues with your speech development. And then there are some differences in home environments between normative kids and kids with language disorders or speech sound disorders. So typically parents are matching speech patterns of children and scaffolding their speech development. And when that's not happening, that can cause some problems. In terms of treatment for language disorders and speech sound disorders, we usually have kids do consultations or therapy with a speech and language therapist. This oftentimes happens in schools. It can also happen outside of schools in clinical settings. Speech and language therapists use specialized materials in order to address whatever specific language problem the child is having. They usually try to use topics that kids are interested in as a way of increasing their enthusiasm for developing their speech skills. Childhood onset fluency disorder is basically when a child is stuttering in a repeated and prolonged chronic way. So stuttering every once in a while is not necessarily a disorder, but if someone has stuttering that causes impairment or is chronic or causes a lot of distress, they may meet criteria for DSM, childhood onset fluency disorder diagnosis. So these disorders may be related to anxiety, although we don't think they're caused by anxiety, but they may correlate with anxiety symptoms. They're also sometimes accompanied by other characteristics like blinking, the child's blinking their eyes a lot, having tics, especially facial tics, or tremors. So these are things that seem to co-occur with stuttering. So most kids who stutter early in life will outgrow it. So 11% of kids will stutter before age 4, but 80% of those kids will recover by the time they're in school for at least a year. So this is a relatively common thing early in life, and then typically kids outgrow this tendency. Girls are affected as much as boys are. And in general, across the lifespan, it's a below 1% lifetime prevalence. So across the population into adulthood, this is a relatively rare disorder. This appears to be a relatively genetic disorder. So we think 70% of the variance in stuttering has to do with genetic factors, especially abnormal development in the left hemisphere. So the area basically right above your left ear, if you zoomed in and you went into your brain, that's where, for most people, language is generated. And so research has found some abnormal development in that area of the brain that may be related to stuttering. There are also some environmental factors that have been relating to stuttering, like premature birth or parental mental illness. Like I said, there's no evidence that anxiety or emotional problems are actually a cause of stuttering. It's possible that they correlate to stuttering, or that stuttering induces anxiety or emotional issues, but it doesn't seem like the underlying cause for stuttering is anxiety. When thinking about treatment, it's important to think about whether this is actually appropriate or necessary, given the fact that most kids will grow out of stuttering. Usually, treatment will include parents using short, simple, and slow sentences to model an unrushed way of speaking, because a lot of times kids who are stuttering are trying to rush the things that they're saying. You can use contingency management techniques. Basically, rewarding kids for not stuttering can be helpful. And then some habit reversal techniques like regulating breathing, taking pauses, speaking more slowly. Those are all ways that can help kids to stop stuttering. Social or pragmatic communication disorder is a new disorder in the DSM-5, so there's limited research on this specific disorder. But basically, the disorder is characterized by persistent difficulties in social use of language and communication. So, for example, kids who have difficulty with conversations, difficulty using social use of language, like making inferences about other people's emotions, thoughts, or intentions. Kids who have difficulty with nonverbal communication, like eye contact, or difficulty with gestures or body language. So, for example, if a child had difficulty greeting people, difficulty taking turns in conversations, they may be the kind of kid that this disorder is describing, the social communication disorder in the DSM-5. This disorder cannot be diagnosed until 4 or 5 years of age. And you may be thinking, well, aren't we just describing autism? And you'd be right that a lot of these symptoms are overlapping with autism. Basically, these are a group of kids who have these social communication deficits but don't meet all those other criteria for autism. So these are kids with social impairment, but they have no repetitive or rigid behaviors. They don't have intellectual disability. So they don't have the other core features of autism that we talked about, but they do have this issue with social language use. So these are kids, in order to meet for social communication disorder in the DSM-5, you must not meet criteria for autism. And so the treatment for this type of disorder is social skills training or peer-assisted interventions. So basically trying to, in a targeted way, increase social communication in these kids. Specific learning disorders, like we talked about, are specific to certain areas. They're not general intellectual disabilities or global delays. So if a child has a general intellectual difficulty, then we're going to give them an intellectual disability, not necessarily a specific learning disorder. And so a child can get a specific learning disorder in reading, math, or writing, and this means that their ability in that specific area is below their expected level given their IQ. It has to cause interference with academic achievement or daily living, so there has to be some sort of impairment involved. And basically this is when your IQ, relative to your IQ, you're having an unexpected academic underachievement. So basically in school you're doing particularly bad in reading, math, or writing, and this doesn't seem to be related to your general IQ. So please read the following silently to yourself. Now Now, when you were reading that sentence to yourself, did you notice that you had to focus your attention on the printed marks? Did you have to think about controlling your eye movements across the words? Did you have to recognize the sounds that were specifically associated with the letters? Did you have to think about the words and the grammar that was being used? Did you have to build ideas and images based on the sentence? Did you compare new ideas with ones you already knew? Did you have to specifically think about storing ideas in your memory? So all those things are just examples of things that kids would have to do who have kids who have impairments in reading have to do some of these things. So we're just trying to highlight that for most of us, reading is a relatively intuitive, fluent process. Kids with reading disabilities have specific impairments in these areas, which makes reading particularly difficult. The most common feature of a reading disorder is the inability to distinguish or separate sounds and words. So while kids are reading out loud or to themselves, it's hard for them to separate the sounds. Dyslexia is an alternative term used to describe impairments in reading. This has to do with accuracy, comprehension, or reading rate. So if someone says they have dyslexia, it's just another term for a specific learning disorder related to reading. Dyslexia is thought, or these specific impairments are thought to stem from difficulties with decoding, breaking words into smaller parts. So there are also specific learning disorders with related to writing. This has a lot to do with hand-eye coordination, or spelling, grammar, punctuation, clarity, or organization of writing. So any difficulty a child is having, specifically related to writing, when you would predict that they would be good at writing based on their IQ. Specific learning disorders related to written expression often co-occur with learning disorders related to reading or math as well. So these are highly comorbid disorders. A specific learning disorder to do with math is just what it sounds like. It's having specific difficulties with math, abstract concepts, or visual spatial ability. Prevalence of specific learning disorders is between 5 and 15% among all the 3 domains in school-age children. So these are not uncommon disorders. Reading is the most common of all the specific learning disorders. And these learning disorders are associated with lower academic achievement, poor mental health and well-being, and lower employment and income in the long term. They're also related to social skills deficits. So of kids with specific learning disorders, 75% of them have social skills deficits. These kids are also higher on internalizing and externalizing problems, so they do seem to have mental health issues more generally. But we're not sure what comes first, so we're not sure whether learning disorders come first, and that relates to causal mechanisms related to the development of these social skills deficits and internalizing and externalizing problems, or whether these issues, internalizing and externalizing problems, are coming before learning disorders. We do know that internalizing problems are often overlooked in kids with specific learning disabilities. In terms of thinking about adult outcomes, a lot of the time kids sort of figure out what they're good at and what they're not good at, and select environments that build on their existing strengths, skills, and talents. So kids with, for example, someone with a math learning disability probably isn't going to go into accounting. So in the long run, learning disabilities may not be as impactful as they are in school, because in school kids are forced to, or I guess encouraged to, do work in all these different areas. But in the long run, people can find career paths that relate to the things that they're good at and don't necessarily rely as much on the things that they're not so good at. People also develop compensation behaviors, so sort of ways of making up for whatever disability they may have. So someone with a pretty bad math disability may always have a calculator or whatever, some sort of way of dealing with their specific disability. We know that there are better outcomes for men compared to women in terms of specific learning disorders. Learning disorders seem to be highly genetic as well, so over 60% of the variance in these disorders relates to genetic disposition. There are also some neurobiological causes, so difficulty bringing information from various brain regions together has been found. Children with one neurodevelopmental disorder are 40% more likely to have a second, so these disorders tend to go together. Treatment for specific learning disorders involves, like we talked about with autism, early detection and early intervention. A lot of these treatments are administered in school settings, so proper teaching strategies are that focus on the whatever area the child is having difficulty with, as well as boosting motivation and self-esteem in these kids. We currently don't have any medical condition or medical treatments, although stimulant medication can improve concentration when kids have coexisting attention problems as well as specific learning disorders. There is an inclusion movement now, so parents and teachers are trying to include kids with specific learning disorders into classrooms instead of having them sort of put into their own specific classrooms. Behavioral strategies, so like we've been talking about contingency management, giving kids rewards for performing target behaviors, cognitive behavioral interventions, and then there are some interesting new computer-assisted learning programs and software that can has been shown to be pretty effective for kids with specific learning disorders. So thank you for bearing with me through this recorded lecture. I apologize for coughing. And thank you guys for a great semester in general. You guys were awesome at participating in class and were super enthusiastic, and that was great to see. There's going to be an assignment posted in Canvas that goes along with this recorded lecture. It'll be called Chapter 7 Lecture Assignment, so please complete that assignment in Canvas. The assignment's worth 5 points, and it is due before Exam 4 on Thursday. So you need to complete this assignment on Canvas before you come in to take Exam 4 this Thursday. Good luck studying for Exam 4, and then also the final exam. Please email me with any questions. And then also, if you have any questions about your grade, please email me before December 8th so that we can talk about it. Obviously, if you have a question about the final exam, we'll have to talk about it after December 8th. But in terms of coursework, assignments, extra credit assignment, all of that stuff, try to email me before December 8th. I won't be available in person after that date, although I will be available via email. Well, thank you guys, and thanks for bearing with me again. I'm sorry I've been sick and wasn't able to come in today. Good luck studying, and I will see you Thursday.